project where we looked at all these agents was that these are that the endpoint agent model of deploying software across networks is incredibly terrifyingly scary. And the reason for that is that what you wind up with is the same code base installed across your network kind of homogenously. And when you think about that, that's actually more scary than an operating system vulnerability would be. Because what you've done is you've deliberately created an attack surface that's common to every one of the machines on your network. A stack overflow or a heap overflow or an integer overflow in one of those systems is more likely to be portable from system to system. You have an exploit that is likely to give you control of more systems doing that. It might as well be an operating system vulnerability if you guys are putting in your default build on those machines and they're going to wind up everywhere. The other thing that's scary about agent-based systems is that the way that they communicate with each other and with their management consoles is complex. It doesn't look that complex on paper when you draw the system out. The agent talks to a management console, the management console talks to an agent, the administrators talk to the management console. Look at that pretty simple diagram. But what you got to do when you're looking at systems like this is look at every end of that communication and think of ways where if the opposing side of that end of the communication was malicious, what control would they gain over the system? So think of that as that at least every component in that graph or that diagram has double the attack surface. You have the client side of every connection and the server side of every connection. But then you also have transitive connections where the administrator logging into the management console sees data that was generated by the agent installation. So you have all sorts of vulnerabilities and attack surfaces that are exposed transitively from all the components in the system. Small increases in complexity in systems like this drastically magnify the complexity, the number of moving parts, the scariness of components that you deploy. You're looking for simplicity, like Bruce Schneier says. Complexity kills. And as soon as you go to the agent model, you added a severe degree of complexity to your system. So the other thing to keep in mind about endpoint agents, particularly extrusion detection ones, is that the functionality that you're exposing is sensitive. And particularly for extrusion detection systems, there are endpoint agents that you can deploy that don't do much and aren't that scary because really they're normal unprivileged applications. In the worst case, you get an unprivileged login to a machine you wouldn't normally have, which you can then use with a local host vulnerability to take over the kernel. And I guess it's just as bad as any other kind of vulnerability. But I'll pretend that kernel vulnerabilities are even scarier. And most of the extrusion detection systems that we look at have kernel components because there's no simple way to ask Windows to give you credit card numbers as they flow in and out of applications. To do that, you have to hack the kernel to cooperate with you and collude with you to intercept all that data. And there's the obvious problem with kernel vulnerabilities, if you've spent any time at BlackHat, is that it's game over. It's the end of the whole system. There's no protection past that. So kernel vulnerabilities are themselves quite scary. So some things to ask. I'm sure Eric can come up with additional questions about agent systems in general. How much of the agent lives in kernel? We'll talk a little bit more about data intercept and where that stuff resides. But what portions of the agent actually reside in the kernel? What is the communication path between the server and the agent? Is it push, is it pull, or is it both? Are there side channel communications? Are there multiple protocols running in between the agent and the server? Sometimes the agent and the server have a secure encrypted channel they talk to each other, and that's the one that you're told to look for. But alongside it is some UDP broadcast protocol. And if you know how that UDP broadcast protocol is formatted, and you format it wrong, and you fuzz the application, you find vulnerabilities that will allow you to take over the agent or the server. We have found systems where the server has the ability to update the agents dynamically. The ability to update the agent dynamically is the same as the ability to run code on the remote system. You've installed SSH without the encryption on the remote system when that functionality is there. Great question to ask any vendor who wants to install software on your systems is, does it have remote software update capability? It shouldn't. And do the agents broadcast their presence? How easy is it to find the agents on the network? Is it trivial to scan for? Are they residing on known ports where it's harder to look for them? Are they running on port 80? Do they send periodic broadcast packets that will let me collect the identities of everybody in the system?
Yeah, I think you covered a lot of it. The thing is, to bear in mind with the agents, Tom talked a little bit about the protocols that may not be readily obvious. Obviously, we talked about the reporting protocol, but there are other protocols. These things that are going across the wire, UDP was one example. For one thing, there are the attack surface that those open, but also you want to be watching that traffic to see how well, what it contains. There may be information in there that might be bear in mind, this whole system deals with sensitive information. And we're going to be talking a little bit about the implications of that too. But on the network, that's an important factor too. So just bear in mind that even sometimes the metadata can be sensitive, and it's something you have to be cognizant of. So while you're looking at the whole architecture, bear those things in mind. Make sure you look at that. Anything else? Okay.
So probably the first distinctive feature of an extrusion detection system and how it would differ from a normal endpoint agent is that the goal of an extrusion detection system is to insert itself into the operating system and detect sensitive information flowing from application to application and from file system to file system. And the way you do that, especially in a Windows environment, is you load yourself into the kernel. And you hook into kernel interfaces that provide you with that information. In Plugboy, there's a variety of different ways that happens. There are file system filter drivers in Windows. In Plugboy, what we have is an NDIS agent, which installs itself as a driver in the system, plugs into the network stack, and intercepts traffic going to and from the box. And what it does with that information is it decodes the protocols going through there. And once it decodes the protocols, it breaks the protocol into its constituent fields and then greps through those fields looking for patterns of sensitive information. The way it does that is it creates a pipe or a channel between the NDIS agent residing in the kernel and a user land process that has the detection engine running inside of it. So it passes that content to the detection engine, which itself runs as a service. This NDIS agent also has the ability to block traffic coming to and from the box. We've never seen that capability turned on any Plugboy installation we've ever seen. We don't recommend that you use it, but that capability is also there. Here's the problem. When you load that code into the kernel, you inherit all the bugs in that code. And what we found when we looked at Plugboy was that it tried to intercept a variety of interesting protocols, including AIM, the Oscar protocol. And I'm going to say right now that when we point out bugs in Plugboy, we didn't make up any of the vulnerabilities that we're talking about in this talk. These are all real vulnerabilities from real systems. They're obscured a little bit, but only the names and the protocols and the applications have been changed to protect the guilty. So, this is as real as we're going to get in the talk, but it's the relatively real stuff. So simple example, real example. You parse protocols in the kernel. Parsing protocols is hard. There isn't a system that's been deployed so far that took on that job and did it successfully. Real Secure had problems with their decodes. Snort had problems with their decodes. But these guys wrote their own decodes all by themselves because it's a fun engineering problem. And they themselves made the same mistakes that everybody else made, including the fact that in the flap/snack headers for AOL, which they're intercepting to see if you're IMing credit card numbers to your girlfriend, they had an integer overflow. They had a field that was supposed to be an unsigned integer counting from 0 to 4 billion to mark the length of the packet. But 0xFFFFF, whatever, in an unsigned integer, if you interpret that as a signed integer, is a negative number. And when they checked for the length of the field, even though it stated a huge length, looked like a negative number, a smaller number than the maximum limit that they were looking for. And so a checked copy inside of that turned into an unchecked copy. And we were able to smash the stack right in the running kernel and gain control over registers, and therefore the execution context of the agent. This is a particularly interesting one because you don't have to make a direct connection to the system to trigger the vulnerability. All you have to do is get the system into a place where it's seeing Oscar traffic that is going to and from the system. So one of the implications is if anybody can make a direct IM connection to the system, that extrusion detection system can be taken out with a single instant message packet. Another problem is that any software that you install on that system after the system is deployed has an instant localhost to kernel vulnerability because all it has to do is make a connection that appears to be like an IM connection that will trigger that decode and therefore expose the system to that vulnerability. This is a straightforward textbook type of vulnerability, but it is one that you will find in extrusion detection systems that you deploy on your network. The way we actually tackled this problem, how we found this was we took the .sys file for it and pulled it into IDAPRO and looked at the disassembly for it. In 2007, assembly code with debug symbols, which were left in the binary, is the same thing as having source code. From the perspective of an attacker looking at a binary at this point, if you've seen, 30% of the talks this year, it's a gathering theme of BlackHat. There's so many different ways to figure out what a block of assembly code is doing. We have really no trouble looking at the binaries and with some effort finding out exactly what the code is doing. But in this case, we didn't even have to do that. All we did was we enumerated what different protocols it was intercepting. And then like every other security testing firm in the world, we have a library of different fuzzing tools for all the different protocols that we look at. And in this case, we found that they were looking at AOL protocols. There isn't a common good AOL protocol implementation out there. What we look for is the most complex protocol that we understand already and that there isn't already a good decode for. We picked AIM, and we fuzzed it, and we found vulnerabilities. So we didn't have to read the disassembly. All we had to do was figure out that it was decoding that protocol, looking for information. Once we found it, we fuzzed it, we got blue screens, and we traced it down into the code and found out what the type of vulnerability was. The takeaway from this, that's interesting, but the takeaway from it is that when you load code into the kernel, there are vulnerabilities in the kernel, and you want to know what types of testing that the vendor did on their extrusion detection system before they did it. You can ask your vendor, and what we're going to do at the end of this talk, we had to spin the slides for this talk before we gave it, but what we're going to do is we're going to build a checklist, and we're going to post it online of things to ask your vendor, just to run through it with your vendor. Did they fuzz test all the protocols that they looked at? It's a good question you can ask. That's what we did. We didn't even need to know much about the application to do it. So that's the type of vulnerability that you'll find in these systems.
Do you want to do these now?
More questions to ask of your vendor about the data intercept component. What file formats do they parse? There's a basic problem. You'll hear vendors tell you that as long as things are in text fields in the data that's going through it, well, they can detect it because the kernel is cooperating with them. It's handing off all this information to them. Isn't that cool, right? There's no way around it, right? Well, you know what? Nothing is normal text on a computer anymore, right? If you take a Word document and you boldface one letter and you italicize another letter, that's no longer the same word anymore in plain text. It's encoded in Word format. So you have a dilemma here. Either you can parse the entire file format so you can understand and do string matching within the application, or you can not parse it and you can miss almost everything that goes through the system. Most vendors will choose to do some level of parsing of different file formats, and they will be proud of this fact, and they will advertise to you the fact that they do decodes for different file formats. The Office documents are probably the first and foremost on that list. I don't know how many of you guys know the Word doc file format pretty well. We do. It's a file system. I don't know if you knew that. File systems are complicated. Word docs are not easy to parse. If they took it upon themselves to parse Word documents, for instance, right? Well, now you have to worry, does their Word doc parse leave them susceptible to malicious Word documents? Not just, things like, are there macros in the Word document? That's, so 5 years ago or whatever, right? It's more like the file formats themselves, the parsing of them will trigger C code vulnerabilities. On the other hand, maybe they're not parsing stuff, and maybe you care about evasion attacks. If they're not parsing individual file formats, bet that there are ways within those file formats that even somebody uninitiated in this stuff could use to evade detection. So you want to know which ones are parsed. You want to ask your vendors how far they go in parsing the file formats. If you ask the question the right way, they'll feel happy about answering that question for you. They'll say that we go through a lot of trouble to parse Excel spreadsheets or to parse zip files or whatever. Unpackers and zip file formats, an excellent one. One thing you should ask your vendors is if they handle zip files, what version of the archiver they use. We find this in whenever we have a pen test on an application and we're looking at an application and we don't find anything, which we just hate. It's not a successful engagement unless we find something horrible. I always go and I remember to go look at the version strings for the zip code. And you always find that they're running something like 10 versions back, which has overflows in it, or a classic oldie but goodie and still appears in modern extrusion detection systems today is the zip file unpacker that will honor ... /... and a zip file as they unpack it and allow you to overwrite any file in the system.